All right, so we are going to start a new unit today. We're going to be doing Unit 11. It's on direct and inverse variations as well as rational expressions. And so we're going to talk about first direct variations today. Pretty easy topic, and that's why we're going to do this with the video. So let's go ahead and start talking about what a direct variation is. Well, a direct variation is a variation of the form y equals k times x. We've actually done something similar to this. You probably remember y equals mx plus b. Well, this is the same thing except without the b. A lot of times we teach this before we even teach linear equations. So a direct variation is just a variation where we have a scalar. The k is whatever x is, you multiply it times some k value to figure out what the y values are. And so with this type of an equation, if the x value goes up, then normally the y value goes up. It could be more and more positive, it could be more and more negative and look something like this. But typically when we think of something varying directly with something, as one goes up, so does the other. The k value is a lot of times called the scalar. That's what we're multiplying the x values by to get the y values. The scalar is sometimes also called the constant of variation. And so if we talk about the constant of variation or we talk about the scalar, what we're doing is we're talking about the number that we're multiplying the x values by to get the y values. So here's an example. Something that is a direct variation. Suppose you get a job that you make where you make $7 per hour. So we would have something like this where the equation is y equals 7 times x. 7 is the k value. If you don't work at all, you don't get paid. If you get 1 hour, you get $7. If you work for 2 hours, it's $14. And the equation is you just multiply these x values by 7 to get the y values. So here's an example of another direct variation situation. 0 becomes 0, 1 becomes 3.5. Can you figure out what the k value is? Well, to get the k value, we'd always take the y values divided by the x values. And it works all the time except for this first one because that's undefined. But 1 times 3.5 is 3.5. 2 times 3.5 is 7. 3 times 3.5 is 10.5. So the equation is y equals 3.5 times x. If we were to graph this equation, it would start at the origin. That's this point right here. It started at the origin, and every time I move over one, I'm going to go up 1, 2, 3.5. If I go over another one, I'm up 3.5, and it's going to be a linear equation, a line that looks something like that. Let's take a look at another situation. So 4 becomes 8.4, 6 becomes 12.6, 8 becomes 16.8. So what are we multiplying these numbers here by to get these numbers here? And it looks like we're multiplying by 2.1. Suppose you didn't know that, you could take the y values divided by the x values. So, and the reason for that is if y equals k times x, if we have to figure out what k is, then I would divide both sides by x, and we would have k equals whatever the y value is divided by the x values. And so that's 2.1. In our situation, k is 2.1. So what is our equation? The equation is y equals 2.1 times x. And if we were to graph this equation, similar to before, we're going to have a point at 0, 0. But then if we move over 1, we're going to go up 2.1. If we move over 2, we're going to be at 4.2. And it's going to be a line that looks like this. Okay, so let's start with an equation. If we have an equation that's y equals 1.7x, well, we're going to have a graph then that is simply, if I move over 1, I'm going to go up 1.7. I'm going to start at the origin because if x is 0, so is y. If I move over 2, I'm going to be at 3.4, and it's a graph that goes through the origin that has a positive slope of 1.7. If I take a look at the graph of this equation, it looks a little bit different, but it's still 0. If I plug in 0 for x, I'm going to get 0 for y. This is the same thing as if I were to write it as y equals 1/4 times x. And so the slope is like 1/4. So if I move over 4, I'm going to go up 1, and the slope looks like this. Still a direct variation. It goes through the origin, and it has a slope of 1/4. The k values can also be negative. This is the same thing as y equals negative 2/3 times x. So if I were to graph this equation, if I plug in 0 for x, I'm going to get 0 for y. But if I plug in, let's say, if I plug in 3 for x, I would have negative 2 for y. And this is just like the slope, down 2 and over 3 to get this point. And it has a negative slope. And so this is an example of one where as x gets bigger, the y gets smaller, but you can think of it as it gets more and more negative. And so these are all direct variation graphs. What you recognize about all of them, well, you should see that they all go through the origin because the y-intercept will always be 0. If there's anything that you're adding or subtracting to these direct variations, then they're not really direct variations. And so they all go through the origin, and they're all linear. And so what do all direct variations have in common? The slopes they all go through the origin, and they all have a slope because they're all lines. The slope is also the k value. So we could think of it as y equals m times x if we were thinking of it in terms as a linear equation. So let's take a look at a situation like this. We have a direct variation that goes through the point negative 4, 3. And so can we write an equation first? Write an equation, should be just an equation, and then find the value of y when x is 7. Well, it's kind of like we have a table of values here. Here's, if I plug in negative 4, I'm going to get 34. They want to know if I plug in 7, what will I get back out? So they do say it's a direct variation, so it is going to be of this form, y equals k times x. So I just need to figure out what the k value is. So I'm going to take 34 divided by negative 4, which means that the k value is equal to, let's see, that would be negative, I think, 8.5, I believe. And so my equation then is going to be y equals negative 8.5 times x. That's my equation, which is the first thing that they're looking for here. And then they want to figure out what is the value of y if my x value is 7. And so I'm going to take negative 8.5 times 7, and that gives me negative 59.5. And so my y value would be negative 59.5. Let's try one more. Actually, I would like for you to try this one on your own first, and then you can, so pause the video, try it on your own, and then restart the video to make sure you have it correct. So what I'm going to do here, hopefully you did this already, is I'm going to figure out what do you multiply 2 by to get 13.5. And so I'm going to take 13.5 divided by 2, and that's 6.75. That's my k value. K is equal to 6.75. And so my equation is going to be y equals 6.75 times x. There's my equation. But then I want to figure out what y is if x is 11. So I would take 6.75 and I would multiply it times 11, and that gives me a value for y that is 74.25. And that's what my y value would be. So this is what direct variations are all about. This is what your homework assignment is about. Homework assignment is going to be in Canvas. So you can go ahead and work on that, and we will go over questions that you have on it tomorrow in class.